Hi students, welcome in today's lecture. So in today's lecture, we are going to talk about a JEE Advanced PYQ based on the electric flux and the electrical field. And if you have not subscribed this channel, so you can subscribe this channel and you can also share this video with your friends. And let us go through this this question of the JEE Advanced, and we'll also learn many things from this question. I will explain this question in detail. If you have the doubt related to the electric flux or how to calculate anything, so you can also comment below. I can explain it in detail this topic, and there are the other videos available on this channel where you can learn a lot about this electric field and the magnetic field and many other things related to the physics on this channel. This time with DK Swami. So you can explore other videos as well. So let us go through this question. So it is given that a infinitely long thin non-conducting wire is parallel to z-axis and carries a uniform line charge density lambda. It pierces a thin non-conducting spherical shell of r radius in such a way that arc PQ subtends an angle of 120 degree at the center O of a spherical shell as shown in the figure. The permittivity of free space is epsilon naught. Which of the following statement is or are true? Okay, so if you go through this question and if you look at the options, so first option says that the electric flux is this much, and the third option says that the electric flux is this much, and then the second and the fourth option they are asking about this electric field. So this is a approach for JEE advanced question. We will read the question and we will also go through the options once before solving the question so that we can get the idea what all things we need to calculate. Okay, and then we'll proceed step by step on the question. Okay, so here we need to first look at the electric field and the flux of that. So you must have the idea about the electric field lines for a line charge or infinitely long wire. If you don't have idea, so then let us understand this one. So like this, I have a infinite wire. Okay, I have given the charge and it is uniform. Lambda is the linear charge density. All right, so like this wire, it is having all around this charge, and because of that the electric field will be like this. If I just represent in the 2D, then these electrical field lines are like this. Okay, okay, if I look in the top view, so then it is something like this. This is our charge. We are looking from the top. It means this is the wire, so I'm looking from the top of this wire. So then electrical field lines are like this all around. Okay, it means if I take a elemental charge here, if I take, let us suppose if I just take this much charge here, then this much charge is emitting the electric field all around in the plane. Okay, something like this. It is not emitting the electrical field in a 3D space, it is emitting the electrical field in the 2D space, something like this, in the form of disk. Okay, so that will help us to find out the flux here. Okay, so what is happening is they have said that the electric flux we need to find out through this one. So basically if I can find out this total charge inside, then I can calculate with the help of the Gauss law that Q in divided by epsilon naught, right? Okay, so here little bit geometry we will do. So for the first option, this infinitely long wire is like this, and we need to calculate the flux through the cell. So there is a one more similar question. I hope I will solve that question as well, or I will upload in short time. Okay, so this is 120 degree. So of course this angle is going to be 60 degree and this is R, so then it will be R sine 60, right? R sine 60. So total length which is inside is L, which is 2 times of R sine 60, and sine 60 is root 3 by 2, so that's why 2 times of R times of root 3 divided by 2, so R root 3 is the length of this wire inside. Okay, and now we can apply the Gauss law. According to the Gauss law we can say that the flux phi is equal to q in divided by epsilon naught, which is the total charge. Total charge can be written down as charge density multiplied by length, which is lambda times of r root 3 divided by epsilon naught. So this is the flux coming out from this complete cell according to the Gauss law. So it means the option first is correct and the option third is incorrect. Okay. Now let us go to the next option B and D. The Z component of the electric field is 0 at all the points on the surface of the cell. So look, they are saying like this, that this wire is parallel to Z axis. Okay, it means the electric field is going to be in XY plane, something like this, isn't it? Because electric field, because of the infinite wire, is like this, so it is parallel to this XY plane. So of course there will not be any electrical field and electrical field's component in the Z direction, so that's why it is correct. The component of the electric field, Z component of the electrical field at all the points on the surface of the spherical shell is 0, and electric field is normal to the surface at all the points. No, because see, here it is normal, but if I take here, then the surface is something like this, and this is the electric field, which is not normal. That is why this is option D is incorrect. So correct option are A and B. Okay. So like this, in this question we applied the Gauss law and we also understood the electric field of the infinite wire. Okay. Likewise, there are the other videos available on the channel. You go through them and learn about the concept and the question of the JEE Advanced. Thank you.